Hi friends, welcome to the Unit 2, Day 3 video. So this is what we're going over, writing the equation of the slope in intercept form, and then write the slope, or label the slope in the y-intercept, then graph and give one more point on the line. This one is actually extremely easy, just to add 2x on both sides. So if I do that, I get y equals 2x plus 4, and then my slope, my n, is equal to 2, and then my y-intercept, b value, is going to be 0, 4. So it says graph and then give one more point on the line. So if I graph this, I'm going to start at 0, 4. That is a point. 2, 3, 4. That is a point. My slope 2, remember the top number, the numerator, is how much you rise, and then the bottom number is how much you run. So 2 over 1. I can go up 2 and to the right 1, or I can go down 2 and to the left 1, and then continue and follow that trend. Whenever you make a line, you always want to use a straight edge. Conveniently, I have my ID that I can use as a straight edge. And then it says give one more point that's on the line, so any point I could give this point here, that point is going to be negative 2, 0. That's another point that's on the line. There's example 3. And then example 4 is the same thing, just a different problem to originate with. So this one, I can subtract 5x on both sides. So that gives me 4y equals negative 5x plus 20. And then divide by 4 on both sides. I get y equals negative 5/4 x plus 5. So my slope in this case is negative 5/4. And then my y-intercept is 0, 5. So now with this one, if I plot this on the graph, starting at 0, 5, 1, 2, 3, 4, 5, I can go down 5, 1, 2, 3, 4, 5, and to the right 4. 1, 2, 3, 4. There we go. And then I can't go down 5 and to the right 4 without taking me off the graph. So literally, these are the only 2 points that I can mark on this actual graph. That's it. That's all. So another point that I could use is this point here, which is 1, 2, 3, 4, 0. Example 5, use the slope-intercept form to write the equation of the line given. So for here, we actually need to find out where some points are. I'm going to go ahead and use, let's see, I can use this point here. Oh, nope, that's not a good point to use. Trying to find, well, here's a good point. There's 1. And that looks to be like 0, 1. Sorry, it's a little grainy on here. And then this one is going to be, looks like it's just a little bit off. Trying to find one where it's kind of in a nice spot. It's a little bit difficult to find because that looks to be like it's just off by a little bit. And that looks like it's just off by a little bit. Yeah, it looks like it's trying to find a good one because this is, see, that's a point. It might be the best one to go off of. It looks like it might be it, but again, it's a little bit up. Yeah, I think that might be the best one to go off of. Negative 1.5, comma 2. Yeah. Use slope-intercept form to write the equation of the line given. So if I think about the slope of here, if I go from 2 over, so I'm going to be going down 1 from 2 to 1, and then over 1.5. Another way of viewing that, in this case, because the graph is a 1-to-1, I'm going down 1, 2, and then to the right 1, 2, 3. So if I'm going down 2 and to the right 3, then my slope here is going to be m equals negative 2/3. You can actually simplify following our 2 minus 1 and then negative 1.5 minus 0, following through with that, and then seeing that it does in fact also give us that. My y-intercept in this case is 0, 1. So if I put these together into slope-intercept form, I get y equals negative 2/3 x plus 1. So there's the equation of the line, given that. There's example 5. We will talk about parallel and perpendicular lines in the next video. Have a good day, friends.